My name is Jason, and I do things with APIs, but I also do things with wiring because I'm building a tiny house. So I've been a hacker for almost 25 years now. I tinker with things as all hackers do. I'm building my retirement home in the driveway of my current home, and then I'll tow it away. And I'm a dad, couple kids in college, and that has been quite a fun run. So what are we going to talk about today? Well, I split this talk into two as you're supposed to, and I'm going to be talking about API security, but I'm also going to be talking about 120 volt wiring or wiring the way it works in the US. Maybe demystify that a little bit, give you the courage to shut a breaker off and change a ceiling fan or something like that. But first, we're going to talk about API security. So the company that I work for is called Sequence Security, and what I do for them is research. I do internal research where I look at data from attacks that are coming at our customers and try to figure out how they're working. And then I also do my own individual original research where I just break things and try to figure things out. So why are we going to be talking about API security? APIs have really become the backbone of the internet, and everybody loves to say that about various things, but APIs are really the data transport, right? They're the tractor trailers of the internet. They're moving everything around for us, and oftentimes they're built for tremendous amounts of speed. And this combination of lots of data, lots of speed means that when API breaches happen, they happen in a very interesting way. Oftentimes it's sucking everything out really high speed. A lot of times there's API endpoints that get stuck on the internet just because. GraphQL endpoints, if you've installed an OpenAPI server, there's a whole bunch of these different places where you can find open endpoints that you can get to, and APIs are just fun. So what do I mean about this? Well, if you look at the left side of the slide where I talk about the old architecture and how websites used to get made and how we used to do things, back in the 90s, my wife was a web developer for a bank. And she told me that, she had to put all these protections in place because some guy named Bob O'Neill had an apostrophe in his name, and that broke his web application. And back then, when you were developing a web application, you actually had to go order a server, get it, install everything yourself on your desk usually. It took a while before that thing was deployed into the data center. And you did everything sort of inside of this server. Sometimes you had two servers, maybe if you had a SQL database, but oftentimes it was a very heavy architecture, very much iron architecture. Now, if you look at the way that apps are built today, we can always ask for data from somewhere else. We can do authentication that way. We can do all kinds of interesting things with catalog and information systems so that you can find out, does Home Depot actually have this sledgehammer that I want to buy? Does Ulta Beauty have the, whatever product it is at the store near me so I can just run over there and grab it? So when you look at how an app is made today, it's just a discrete data exchange with the end user, but then there's all this other stuff that's happening on the backside. When I talk about this, I usually mention Uber, right? Or an app like Uber, like Lyft or something like that. You say you need a ride on your phone, the location that you're at, all of your payment information, your account information is all going to be interacted with in some kind of cloud environment, as well as all of the drivers near you and anything that is pertaining to where you're going and tolls, and just all of this stuff gets called up and figured out all in this platform system that's making a million API calls back and forth. As an API security company, we see a lot of places where people inject whatever it is that they want to in order to kind of satisfy their means. So what kinds of things happen out there in the world? Well, account takeover, it was a big thing back in the 90s. on websites when you could just literally send in usernames and passwords over and over and over again. Well, we rebuilt that system. When I was, recently, when I had recently joined the company, the lockdowns all started happening and I was stuck at home. So I have a greenhouse here. So I started planting a bunch of different stuff in my greenhouse and I got really involved in my greenhouse. And something started eating my cucumbers and I had no idea what it was. And so I bought a little camera and I set it out there. And while I was waiting for whatever this was to come along, I started looking at the APIs that the camera used and realized that if I send in a bad username, I get back error, bad username. And if I send a good username but a bad password, I get back error, bad password. Well, I can use this to enumerate a list of email addresses to figure out which email addresses have accounts on this system, and then I can use that list to figure out what their passwords are. That's kind of a bad thing. Well, this is how account takeover attacks work. In an API environment, there's not a lot of checking. It's high speed. We're trying to do as much as we can, as fast as we can. And that's just kind of a common example we see a lot of. We also see things like seat spinning, where you'll actually take over somebody's inventory by locking it into either a shopping cart or into a transaction that takes a long period of time. So if you think about airlines, for instance, when you decide you're going to fly somewhere, the time it takes from you to make that decision and actually get to the point where you say, I want this seat on an airplane is a pretty long period of time. And so that seat, by the time you say, I want that seat, has to stay in place because everyone else is coming at that same long period of time, that slow speed. And so you can tie up all the seats on an airplane for a very short amount of time, but you could potentially tie up all the seats on a plane as a seat spinning exercise. Now expand that outward. Anything with inventory is completely possible. Hype sales are another place where we, as a company, have done a lot, but where I've actually got to see quite a bit of attack and all of the different places that these come from. And with the exception of account takeover attacks, hype sale attacks are some of the easiest attacks. And I know Taylor Swift would be mad at me for saying that because Ticketmaster obviously proved that it's difficult, but they are actually pretty easy to detect. You just have to do this through behavioral analysis. And I'm going to talk about how that happens here in a few minutes. Data theft. We've seen so many times people just suck all the data out of a database. Being able to get on the API layer for things like GitHub and stuff like that means that you can do things like code infiltration. And my company pretty publicly works with a lot of ISPs, telecom companies, and we see SIM swap attacks come in over the APIs all the time. If you have an API if you work in an ISP and you have an API where people can do SIM card changes, odds are there are SIM card swapping attacks that happen there. Why do they happen there? Well, we suddenly fell on this sort of two-factor authentication, and everybody went, what we'll do is we'll just put it in an SMS, which is a bad idea because what happens if you no longer own that phone number? You now have all of a sudden this SIM swap attack happening. And there's been some pretty famous cases that came out about this. A friend of mine, Aaron Ansari, talked about the Coinbase attack at one of the conferences I went to recently, and it just cracked me up. Some 17-year-old kid orchestrating this massive SIM swap by stealing an iPad out of a T-Mobile. It was absolutely nuts. So what are the real problems that happen here? Well, good news is we've got something called OWASP. And so OWASP API top 10 kind of helps us out. Something you need to know about this top 10 and the way these top 10s are made is this particular top 10 has to do with testing. So if you were to sit down and test an API or test 10,000 APIs, your biggest problem that you would find is that first one, broken object level authorization, right? We call this BOLA. But what this is if I'm in Facebook on edit profile 1, 2, 3, 4, 5, and I change it to 1, 2, 3, 4, 6, and I actually get that profile, that's BOLA. I'm not supposed to have access to that object. I'm not authorized as an end user to administer that object, but I'm allowed to do this. And you'll notice I've got a couple of these in yellow and a couple of these in orange. The ones in orange are the ones that are kind of important. And it has nothing to do with testing. This has to do with what I see in the world as my customers get attacked. So what do these attacks, really look like? Well, they almost always come out the same way. And I apologize that if you are in Australia right now, because you probably have heard someone say Optus in the last year. And if you're not in Australia and you've heard somebody say Optus in the last year, I apologize that you may be getting fatigue on this, but it's a great example of what I'm talking about. I find an API endpoint that if I send a phone number to it, it gives me back everything it knows about that phone number. So if I can write a really short Python script, I can just keep iterating phone numbers and keep getting data back. And Optus is a telephone company in Australia. They own about 3 million end users in their line of business. There's about 9 million people in Australia. So they have a third of the market. And somebody figured out they had this endpoint that they didn't know about, was unauthenticated, and was extra chatty. And I'm going to focus on that as we go through this. But all of these kind of end up that way. Peloton had almost exactly the same problem. And the researcher that found it, just like Chris, the guy that was before me in this, talked about, when you drop into that idea that you're going to be living sort of in this world of responsible disclosure, you're expecting them to treat you like a normal human, and they just brush you aside. And it's like, hey, I'm trying to tell you, you got a problem here. The Peloton, the responsible disclosure that happened with Peloton is they told them, you have this problem. I can see someone else's data. And they said working as designed, right? So he went and found, the researcher went and found a reporter's data and sent it to them. That got their attention, and it got them to actually do things. But you can notice a lot of these have kind of the same flow and the same problems, and it's all really kind of the same problem. So let's kind of dive into sort of how this looks, or what this looks like. So I'm going to talk a little bit about an organization called Fly.io. And Fly.io, you should be seeing Fly.io on your screen here. They do something with servers or something, I don't know. But what I'm going to guess is that they have an API. So I'm going to type api.fly.io because a lot of us use very common, standard, nomenclature for things. And so when I look at this, what I'm seeing is there isn't anything there, right? There's a 404. But what you have to remember is a 404 is telling me there isn't anything there, but it is telling me there's a there. What it's telling me is I requested something that has a valid domain name, but it just doesn't exist on this server. And because, if you guys know web at all, I didn't put a trailing slash on here or anything, so it's going to assume trailing slash index.jsp is going to try a couple of different things, but it's not going to get there because I never defined any of that in the web server. But just simply because I know that this endpoint's there, I can start asking it questions like, hey, do you have a GraphQL endpoint? And this particular organization, and you have to realize this isn't a vulnerability, this is their demo site, so it's supposed to work this way. You can go mess with it if you want to. This is how it's supposed to work. But api.fly.io/GraphQL loads their GraphQL playground to me. Isn't that an interesting thing? And I think that it is, because it's telling me that they have GraphQL in this environment. Now, are they aware of this? Well, that could be a yes, and it could be a no. And I'll talk about how you can become more aware of this as we go on. But what we're going to talk about is, what do these API calls, actually look like? So here's a response, right, where I've got this big JSON object, and it's it's giving me all this data back. But let's just focus on the request here real quick. And so I use Burp Suite. So this is just a copy out of the Burp Suite headers, right? So I send a request in to customers at example.com. Sorry. And what I'm trying to do is figure out, can I get from customer 1 to customer 2? So you can see I've tokenized the customer position. And in this, I can iterate through numbers or letters, or I can stick GUIDs in here, or however they've defined this on the way that it works. So let's step down through this a little bit. The host, this is where I'm trying to go. The user agent that I'm using Mozilla user agent, Firefox user agent. And as we slide down, you can see what I accept and the different things that I have a good understanding of from this website. In its response, you can see the server allowed for it to happen. It's telling me a bunch of stuff about headers and different things that it accepts and what it does. And then you can see the data in the response. And so this request response in APIs looks exactly like it does in web, with one exception. The response doesn't contain anything for the website to use or for the web browser to use. It's not telling the web browser, hey, formulate the page this way and say account ID and put this in on it. It's actually just sucking the data back, right? We're just moving the data around. This really shrinks what it is that you're moving. And it's the reason why the adaptation of APIs has gone on the way that it has. There's so many more people doing APIs now. So now you've seen, here's what a request looks like, and here's what a response looks like. So why are API attacks working? I mean, what is it that makes them work? And so if you kind of break it down into, what mistakes are there being made, it's these sort of three things, right? Unknown endpoint. I didn't know it was there. In Optus and Peloton and a bunch of these breaches, their very first thing that they share with everybody is that was an endpoint that we weren't aware of. And so being aware of your endpoints becomes really important. It's not just looking at things like, what requests are making it to the endpoints the most. It's which endpoints are actually available that I need to secure. So what you might be noticing here is I'm talking about simply understanding, cataloging, what endpoints it is that you have. But you have to understand that a lot of stuff, when you turn it on, you get defaults like GraphQL, and like OpenAPI gives you swagger.json, and there's a bunch of them, right? The next thing is, are the endpoints authenticated? Is there actually authentication that goes along with these endpoints? Either it's an entry point and there isn't authentication expected, or you should be authenticated now, right? And you need to be authenticated here. When you first stand up a Jenkins server and you don't have any security headers, you are the admin. You don't have to put an administrative credential in it. You don't have to do anything. And a lot of times people don't shut that off. So when you show up to a Jenkins server that's challenging you for authentication, strip the auth header out and see if it'll just make you the admin, right? Understand, should this endpoint be authenticated or not authenticated? And then the next thing, or what we in the scanner business, back when I used to do web scanners, would call the authenticated endpoints, right? Where you need to be authenticated in order to see this, things like account data. Test to make sure that you can't get there with 256 A's or no authentication header or just random stuff in the authentication header. Check to make sure that it's not just doing a check to make sure the authentication header is there. And this last point is the most common mistake that I notice, with organizations is they future-proof their apps, right? They make them extremely chatty. They put a ton of data inside there, and it's stuff that just doesn't need to be in there. When the lockdowns first started during the pandemic, my local pub, which has the cheeseburger that I like the most, had to suddenly become an organization that took online orders when they didn't used to do that. I joke all the time. Go back 10 years, walk into your favorite bar and say, hey, in 2 weeks, I want you to bring me a whiskey out on the curb. They're going to just laugh at you. And a lot of states did that, right? During the pandemic, it's how liquor licenses, it's how they could keep their taxes and all that kind of stuff. And so they had to get a system. And so they got a system. And of course, I browse the web through a proxy usually. And I noticed that in the responses that were coming back to me was the administrator over at the bar's name, their phone number, what level of service that they had with the organization that was doing their online services for them. It was stuff that just doesn't need to be there. And it's stuff that you can use, frankly, during a social engineering attack. And so you definitely don't want that stuff there. You definitely don't want to try to have that stuff there anyway. So pushing this kind of future-proofing idea doesn't always work, right? So if you want to find your endpoints that are out there, there's a couple of different ways to do this. One of them is called Kite Runner. It's by Asset Note. And what they did was they went out and they ran Google BigQuery on GitHub and found out what all the common endpoint names are. And then they put that in here. So they allow for you to test to see, did we put any of the common endpoint names in place? I'll warn you, this generates a lot of false positives, but it is something that you can do. Paying the bills, Sequence has something, and that's really all I'm going to say about that. If you want to talk to me about it later, I'm happy to talk to you about it later. Look for things like /GraphQL, /Wagger.json, /Explorer. If you go look at that word list on Asset Note and it's big, you'll notice a whole bunch of real common things that are inside there that are very common endpoints. And they'll allow for you to find some of these default endpoints that get installed with whatever platform. Like if you're running Kubernetes and you have a database and stuff, you probably have a GraphQL endpoint that you're unaware of. And so you may want to know about that. And this last piece that I'll talk about with this is APK file decomposition, where APK files are the files that Android apps come as. There's plenty of repositories for them. Every version of every Android app that has ever been made has its APK file stored someplace where they probably didn't intend it to be stored, and you can go download it. And you can use that to find endpoints. I've had customers call us and say, hey, we're getting attacked on this endpoint that we never, let you guys know was out there because we never intended it to be used. And somebody's using it because we left it on. And can you please help? And we look at it and it's just sitting in their APK file and it's easy to find. And once you understand how to decompose an APK file and look for API endpoints, you end up with all of the API endpoints that are common or used for almost every application. So you can figure out what the API endpoints are for a banking application, for instance. I taught a class on this for OWASP back in like 22. And there's YouTube videos on how to take APK files apart. I'm not here to discuss it in great detail today, but if you have questions about how to rip an APK file apart, I've got a pretty good Docker file that'll help you get there. So how do you mitigate all these risks? Well, peak mitigation is doing behavioral analysis, and I'll take account takeover as like a really simple example, right? I've got this user who's shown up from 29 different countries using 8 different user agents, right, trying to log in. Well, that's an account takeover attempt. It's really not that hard to figure out. Once you read these words, it's not that hard to figure out. Now, implement it technologically, right? Install the thing I just said. That's a little bit harder. And so we're going to have to, break that apart a little bit differently and say, you need to have data science and you need to count things, right? So look at what you need to count. User agents, you need to count countries. So you need to be instrumented so that you can figure out what countries things are coming from. And then you need to count how many times has this user shown up today. But if you can just do regular Bayesian analytics, right? Machine learning is just comparing 2 things and how they normally look. If you can do regular behavioral analysis through using these behavioral analytics, you can say, well, geez, the 3rd time this user showed up from a 3rd different country, I should just start throwing this user's traffic away. And this can go on. It depends on what your business is and what it is that you do for a living. But this can go on and on. Look at gift card enumeration as another, really good example. I actually stopped gift card enumeration, and for one of my customers that I have, they had a gift card program, but they were like really easily guessable gift cards, and they had like a rewards redeem. You could see how much value was available on an API endpoint, and somebody just pounded on that thing with millions of requests, iterating through numbers, finally figuring out which gift cards were valid, and then going and spending the money. And so when you start to look at some of these things, they're easy to see through behavioral analysis. Little aside here on API gateways, because we often get questions about this. Gateways, think of them as routers. They'll move the data to wherever it is that you need it to move to, but they haven't layered in a lot of security. Many of the gateways will say, yeah, we have security that go along with this, but it's very rudimentary. It's not behavioral analysis, which is where you need to really end up. So in summary, there's APIs out there. Often they aren't authenticated, and many contain the data that they shouldn't, right? So shifting gears to the other side of this presentation, I'm going to talk about household wiring. I apologize if you're outside the United States, because some of this isn't going to apply. But if you're inside the United States, you own a home, you live in an apartment, whatever, and you really want to change that ceiling fan, you want all of your outlets to be bright white instead of ivory, you want, to change things out, you don't have to go hire a licensed electrician to do very simple things in most states. Now, not every state is the same. It also depends on the application here. You're going to notice I'm throwing a lot of kind of preemptive, don't go do this without a lot of study kind of stuff in my talk here, but I'm not an electrician, nor am I an electrical inspector. So how in the world could I know this? Well, it's two wires, right? It's really not that hard. It's just, we've been taught you just shouldn't touch it because it's going to hurt you and all of that kind of stuff. And that's true. If you stick your wet fingers into a live circuit, you are going to get electrocuted. And it's going to happen. It's going to hurt. You're not going to enjoy it, and it might kill you. So don't get killed. All right. There's a few assumptions that go along with this talk. You understand that there has to be a completed circuit in order for electricity to flow. That's part of it. You also understand that I'm going to be using a couple of different terms that mean a few different things. And everybody will, have the chance for this deck, and it'll be out on the recording and stuff. I broke some of it down here. There's math that goes along with this. I was on a submarine in the Navy, so submariners have to learn basically everything. And I was an electronics technician, so I did a lot of that. And in my electronics technician job, I was a sonar tech, so I also did a lot of math. But we had to learn every system. I know how a nuclear reactor works. I know how refrigeration works. I know high pressure hydraulics. All of these systems are very simple, very basic. And so you can understand them in a fairly basic way if you understand a few of the different things. Like when somebody says, this is a 1200-watt toaster, you can figure out real quickly how much resistance is in the strips, because 120 volts, 1200 watts is 10 amps, 10, you can figure it out really quick, 10 ohms of resistance. So what I'm trying to get across here is you can do the math quickly and figure this stuff out if you understand the formulas. So I've given you kind of the formulas here so that you can sort of work things out, and I'll give some examples kind of as we move along. I'm talking all about US. Most of the appliances in the US are 120 volt AC, with the exception usually in a house is the dryer. That's usually a 240 volt. And then further exceptions when you get to places like my house, where I've got, Bitcoin miner that's running 240, and I've got my tiny house plugs in at 240, and, stuff like that. So you have to think about this stuff. So I don't know how many of you have taken the panel off of your breaker box, but this is what it looks like if you take the panel off your breaker box. It's the breakers, the lines leading off the breakers, and the rest of the circuitry that's in here. So you see this black line on the left, and this red line on the right are indicating things like how much power are coming in. All right. So in this particular breaker, I've got 220 volt lines coming in, but they're out of phase. So if you measure peak to peak on the distance there, we're going to get 240 volts, right? So each one of these breakers is plugged in to a bus bar that is setting this up. And then there's a safety mechanism that gets put in here called the neutral. And the neutral is how we split these loads in half so that way we can have 120 volts, right? You'll notice there's a big bar that goes across from one neutral to the other. All the bars are all plugged in the same. The grounds are plugged into the neutral bar, right? So this neutral bar is kind of important. But the real important one is the black one and the red one. Those carry the 120 volts each that are out of phase. So when you run them together, you get 240 volts. If I take one away, remember that discussion I had earlier about how we have to have a circle in order for a circuit to work? That white line is the other half. So we've got the black one running at 120 volts and is sending its voltage back on the white line. The red one running 120 volts and is sending its voltage back on the white line. It sort of breaks apart like this. If you were to follow it out to your house, you've got a hot bar. That's one of those, it's either the black or the red line that comes out. And then you've got a neutral line that goes back to that bar that's there in your breaker panel. So your breakers are set so that if too much power is pulled down the circuit, right? If somebody plugs in something that's going to draw way too much power, the amount of current is going to go way up and it'll go past, in most household environments, 15 amps and the breaker will trip, right? And then there's no power on the circuit and the circuit is safe. And that's what you're trying to do when you put all these things in this way. But you'll notice there's all different kinds of plugs and weird things that you can put together. So I'm going to break it down a little bit easier. Coming from your breaker box, you've got 3 wires, right? I said it was 2, but there's a ground. 3 wires come from your breaker box. The black one is plugged into the breaker. The white one is plugged into that bar on the side, and the ground is plugged into the bar on the side. Why? Well, you see how your light switch has a bunch of metal around it? Well, what happens if that hot line touches that metal and then you reach up to grab the switch? Well, you could potentially get electrocuted. So they ground everything out so that way it'll draw a ton of current and trip the breaker. The whole idea here is trip the breaker in order to make it safe. So this is really, really common. This is when you flip on just a light and it lights up your room or lights the light closet up or whatever in your house. You'll notice the only thing that's being switched is the black line. The white line just continues on up to the appliance. The copper line is being pulled over to ground the switch out as well as ground the appliance out. It goes up and grounds that out. The only line that's broken here is the black one, and that's the switch line. We call that the hot. That's a real common switch. These are the switches that when you go to the big box stores cost, $4 each or whatever. Now, some of us have 3-way switches where you turn a light on at the bottom of the steps and you turn it off at the top of the steps. That's the most common application. In my tiny house, I've got one switch that shuts all my overhead lights off in the whole house. But I've also got, individual switches that can turn things on and off. It blows your mind the way this works, but think about it for a second. So the line coming in from the very, very left side of the screen is the one that comes from the breaker box. You'll notice your whites are all tied together. You notice your grounds are all tied together, and that just continues on all the way through up to the light. Only thing we're messing with here is we had to add a wire, and it's called a traveler wire. When you turn the switch on, it's going to send power down that traveler wire, and that traveler wire is connected to the black wire that goes up to the light bulb. It's also, when you turn the switch off, you can turn the switch on, and it links on the right side switch the black and red traveler wire terminals together so that you're powering it, right? And then you're sending the power off down the line. It's this weird thing, but you got to have three-way switches in order to make it work. And what it does is it sets these gates up that allow for power to move back and forth and around. It's a kind of oddball situation when you think about how things are wired. This is a very common three-way wiring. Now, if you were to take this entire scenario and make that a ceiling fan, often ceiling fans have two wires that go up to them. You rarely would make this a three-way switch. You'd put this back to just a single switch turning the light on and a single switch turning the fan on. But oftentimes you run the same kind of wires, the ones that have extra wires up to a ceiling fan, because the fan and the light are separate. And I just put in a remote fan and they weren't, and it blows my mind because I'm like, the fan and the light are on when one switch, it shouldn't be that way, but it is. And I guess that's how we're doing it now. They got remotes for everything. I personally can't wait till they stick my fan on the internet. You know what I mean? People can hack me through that. So why are we talking about all this? Well, like I introduced at the beginning, if you want to change your light switch out, a lot of people are just afraid of it. I've got a close neighbor that calls me anytime anything electrical isn't happening because he thinks that I have magical powers about electricity. It's just a couple of wires. The breaker shuts the hot one off. It's not a lot of, there's not a lot to it. There are exceptions and there's extra things. If you're going to put a shed out in your, back garden and you want to run power out to it and have a, I don't know, Tesla charger out there and stuff, get an electrician. All right. You're going to need some extra things going on with sub panels and all that kind of stuff. But if you just want to go switch your light switch out, if you don't like that your outlets are the kinds that they are, or you want to put USB outlets in, I've done that, a bunch of my outlets, broken ceiling fans, whatever those things are. But keep in mind, I'm trying to help you save a little bit of money, improve your quality of life, make yourself a little bit happier, just so that things go out okay. So I said that, and I talked about all the power. So what's the safety stuff? What's the things that you should do to make sure you don't die? All right, this is super important. Find the fixture that you want to fix, right? So say I want to change out my light switch, right? It's going to have one power line on it. If it's not a three-way switch, I want that power line to be off. So what I'm going to do is go find the breaker for that power line. There's a couple of different ways that I can do it. They make little tone generators and all this kind of stuff that you can hook on there, or I can just flip it on, walk down to my basement, flip the breaker off, come back upstairs and see if the light went off, or have somebody in the room with me or whatever. But turn it off, right? Find the breaker for it to be off, turn it off, and then check it dead. Klein makes a power sensing little thing that you stick next to it, and it'll beep if it senses power there. You can put a voltmeter on it and measure it, but check to make sure that it is dead. And don't just lick your fingers and touch them on there. That's not the best way to do it. You're going to end up with bad headaches if you do that. Once you know the fixture's dead, swap it out. You're going to want to follow the same way it's in there. If the little loop's looped around the screw a certain way, you want it looped around that screw a certain way because that's going to have the best connection and tension. It's not going to back out on you. It's not going to come off. So pay close attention to that. Go find a YouTube video on whatever it is that you're doing and learn how to swap those things out. I don't like backstabbed connections, but people do that and people make light switches that you just stick the thing in the back. I don't think they give you a good connection, but that's, there's personal opinions that go with everything. Things that you should probably never do are things like swap out breakers. Anytime I swap a breaker out, it's usually because I'm out of space in my panel and I need another 15 amp breaker, and they make it's two 15 amp breakers as one breaker. I know it's terrible. Don't do it. Yeah. Let me run my house my way. But what happens with a lot of these circuits and a lot of these things is you add and add and add to it over time. And then one day you flip the switch on for a half hot or something else, right? And it blows a breaker or causes some kind of problem. Had a really close friend that had a 15 amp breaker go bad. The breaker went bad. It tripped so many times it went bad. And so what was his solution? Get a bigger breaker and put that in. We have to realize the wire running through your house isn't set up for that, right? Most 15 amp circuits, that's your light switches, your fans, that's almost all of your plugs, right, are 15 amp circuits. If you look in your breaker box, it's almost all 15 amp circuits. There's a few 20 amps in there, probably your fridge, maybe your microwave, right? Stuff that draws a lot of power, but only that thing draws that power. 15 amp circuits tend to be chained together a lot. So, you know, you probably had this happen before where you have a breaker trip and suddenly 4 outlets don't work. And that's because they're daisy chained together, right? That's very common practice. So when you start to get through all this, you start to realize that all of these things are built to code and for a reason. Some states and some cities and some municipalities, they don't let you touch anything electrical. They make you pull permits and all of that. But almost every place has an owner permit. So you can go do things like changing out switches, changing out fans and that kind of stuff. So keep in mind, you just got this black wire, it gets switched back and forth, right? And you got power wire that comes in from the outside. That's how almost all of these circuits are designed. But then you've got a whole million plugs out there in the market. And I put this in because everybody has a dryer. When you buy a dryer, clothes dryer, it doesn't come with a cord because they want you to match your plug. And one of these might be it. And you'll notice whether or not is there a white wire on these. So the 650-R, you'll notice, is just hot and hot. It's just the 2 reds and a green. That's the 3 plugs that says GYX in the middle. This is what my welder outlet is. This is for my welder. It runs off 240 volts. The 120s are the return path, right? Some people have dryers that are like that. Well, how do you have anything be 120 volts in that circuit? Well, you just grab half of it and run it down the ground. And that's what they did for a very long time until they realized they needed more 120 volt power. And now you've got a 1450R, which has a dedicated white that goes on it. It's changed. Why did it change from 3 to 4 prongs? Is they put more 120 volt stuff in the dryer. The reason it's 240 volts is the heating element, right? And that's the reason why it went that way. Partially switched receptacles are what we call half-hots. You flip a switch and the lamp over in the corner turns on. It's simply them breaking a tab off and running wires this way. It's a very simple thing. If you have questions about this kind of stuff, feel free to ask me. Go to YouTube, do all that kind of stuff. But turn it off, check it dead, and keep in mind, there's lines that come into the top of the panel that bolt into where your main breaker is. Those lines are still hot. Don't touch them. When you flip that big breaker, you're shutting all the little breakers off and all the power to the bar down there. But those big lugs at the top that I showed in that very first slide, they're still there. They're still going to cause you problems. So I'm a little bit ahead of time here by like 2 minutes. But I'm Jason. I broke into a garage door API back in like 15. CASA API disclosure. I've done a bunch of things with GraphQL playgrounds and Swagger files, as well as build my own tiny house. And I encourage you to go out and do whatever it is that you want to do with your life, because why not? Somebody else is probably going to try it. Let's go figure out how we can make things better for everyone on the planet. And then we'll have a planet that we all like to live in. I'm ready for questions. Mel?
Awesome. Thank you, Jason.